All right, guys. Hopefully this works for you guys. Let me raise this, make this a little bigger. Okay, so we've kind of gone over this before, guys. So this one, don't forget uh, that if we're going to calculate and interpret the mean here, we're going to put this into list one. I better shrink that down just a little bit, guys. It's going to be in list one. Sorry, list one. This is going to be in list two. And then uh, list one and list two. So that'll do that. That'll put that in list one and list two. And then you're going to do one var stats for the list one versus list two. You could do a histogram if you needed to. Don't forget your minimum X would be 11 and your maximum X would be 19. And then you would change the Y value to 0.5 again. See how that's 0.3, so you don't have to go higher than 0.5. So really practice on putting that in from page 348, I think it was. Page 348 if you want to do that. So once you put it in the calculator, it's going to kick out 14.65. And just remember that's the average number of units that a student takes at El Dorado Community College. And you find that, remember, you have to set it up. So you're going to do 12 times 0.25, which is this one here. And you have 13 times 0.1, ... And you should be good from there. And you'll kick in what you get out from one var stats. Standard deviation, the same thing. Use the formula sheet. It's going to be x, which is 12, minus our expected value. Square that, multiplied by the probability. Do that twice in a row, ... Put in the answer from the calculator. And I ran out of room here, but don't forget that's on average, a college student takes 2.06 units more or less than the mean of 14.65 units. So just remember, it's how far away from the mean it is. Now, we've talked about this before. So we're going to take the value and we're going to say that the number of units is multiplied by 50. And we've done this before. If we multiply the number of units by 50, we're going to increase the expected value or the mean by 50. So we're just multiplying those two to get a new mean of 732.50. Same thing with the standard deviation. The standard deviation gets wider. And so we're going to do 50 times the standard deviation, and it gets bigger and bigger. And so it's going to get 50 times bigger, so it's 103. So then on average, a student pays $103 more or less than the average of $732.5 for the units. So when we multiply, our center and spread get larger when we're multiplying by big numbers. If we're multiplying by fractions, it'll get smaller. So then from there, what if we add a $100 flat fee assessment? Well, you don't have to put this all back in there. Just remember now that we're adding $100, so it's going to shift the mean to the right $100. So this is going to be $832. I can't write on this right now. $832.50. And then $803.50. And standard deviation doesn't change at all because all we're doing is shifting the numbers to the right by $100. So effect of adding and subtracting are variables. For a random variable is the center moves left or right, and then the standard deviation or the spread stays the same. So it doesn't really matter. So what is linear transformation? Linear transformation is all of it together. So C equals 100 plus 50t. It looks like a line. So linear transformation is just our multiplication and our addition transformation all in one equation. So from there, we take that idea and we get an equation here of we're gonna multiply the raw scores by 4 and add 10. So my raw scores are x. So I create an equation, y equals 10 plus 4 times x. And then we know that the mean is 17.6, and that's the distribution of the raw scores. So then at that point, we know that the mu is 10 plus 14 times 7.2, which is equal 78.8. And that is my new mean for the test scores for the scaled test score. And then my standard deviation, the 10 doesn't affect it, because part of the linear transformation is the 10 doesn't affect the standard deviation. So the standard deviation is just 4 times 3 times 8, 3.8, which is 15.2. So then on the second one here, they ask about a standard scaled score less of at least 90. So we're working of at least 90. And so we are, and I don't know why I put it that way. Why did I do it that way? It should be the other way. This should be a greater score of 90. At least 90 is greater than. So these are reversed. I didn't use my calculator. I used the table. So these should be reversed. Those should be lower boundary, upper boundary. And then we can use normal CDF at this point and plug everything in, and we get our 22.96%. Now, this notation right here is not that big of a deal. This is normally distributed with a mean of 78.8 and a standard deviation of 15.2. So when you see this notation right here, that's all that means. So that's our notes today. We got caught up. We'll talk to you guys soon.